Hello. So after studying so much, our position is like this. We understand very well what is substitution reaction. We understand very well the difference between nucleophile and a base. We understand very well nucleophile causes substitution. We understand very well that a base causes elimination. What we don't understand very well is elimination reaction. So the plan is like this. We'll study elimination reaction both E1 and E2. Then we will do a comparison between substitution and elimination. SN1, E1, SN2, E2 and substitution elimination in general. That would complete the entire syllabus of reaction mechanism. Then we'll be fully prepared to start one by one each name reactions and finish them one by one. So to proceed ahead with elimination, as we started substitution with SN2, in the same way I'll start elimination with E2. That's easy to understand and that's how I like it. E2. So let's have a substrate as chloroethane and let me have a base in the system. Now this base, you understand, this base is a reagent that has a negative charge. That's want to get rid of its negative charge, and since this is going to react with a hydrogen, we call it a base. Now since we have written it as a base, we understand that this is going to react with a hydrogen. Now I have moderated the reaction condition in such a way that this reagent is going to react with one of the hydrogen. So I'm calling it a base. Now later, once we understand the mechanism, then we'll understand how to moderate the reaction condition, and then we'll compare how to moderate the reaction condition to prioritize substitution over elimination or elimination over substitution. Alright, but prima facie, to start with, this is a base, this is going to react with one of the hydrogen, this is not going to cause substitution. Now there are two hydrogens, two positions of hydrogens. One is alpha with respect to leaving group. If leaving group, the carbon attached directly with the leaving group, that is alpha carbon, and subsequent carbon is beta carbon. Hydrogen on alpha carbon are alpha hydrogen and hydrogen on beta carbon are beta hydrogen. So there are two types of hydrogens, alpha hydrogen and beta hydrogen. Now elimination by and large would be beta elimination. Most of the time, in 99% case, base will abstract hydrogen from beta position to facilitate elimination. Now why it abstracts hydrogen from beta position, that becomes evidently clear once we look into the mechanism. Let's see how reaction actually happens. This will be the orientation of hydrogen and chlorine. They will be anti-periplanar. That means they will be on opposite sides of the plane of the molecule. And now we have a base. Now base will react with hydrogen because the bond of hydrogen is a weak bond. So base will abstract hydrogen, forming HB bond. So base is stabilized, forming HB bond. Now since we are studying E2, so the mechanism of E2 would be such that base will gradually abstract hydrogen. Abstracting hydrogen meaning it will form bond with hydrogen, it will put its electron into the orbital of hydrogen, and hydrogen will give away its electron into the orbital of carbon because it is accepting electron from an outer source, that is base. So the electron in the base will be utilized to form a bond with hydrogen, and the electron with which hydrogen is already forming a bond, that will be pushed into the orbital of carbon. Now carbon will start to become excess of electron, and carbon also have to find some way to get rid of that excess growing electron into its orbital. Now there is no other bonding orbital empty, but there is an anti-bonding orbital of this carbon. So what would happen is electron from this bond, which is getting accumulated into the orbital of carbon, will start to transit into the adjacent anti-bonding, which is parallel to this bonding. Now that has to be parallel or almost parallel for electronic transition, and this we have seen million times before, that for any electronic transition orbitals have to be parallel to each other. For resonance, p orbitals have to be parallel. For hyperconjugation, the CH bond has to be parallel to p orbital. Actually, because for CH bond we have a p orbital, hybridized p orbital. That hybridized p orbital have to be parallel to pure p orbital. For resonance, both the pure p orbitals have to be parallel. When the orbitals move away, when they become tilted, then the extent of resonance or electronic transition in general decreases. When it becomes perpendicular, electronic transition becomes zero. It becomes so negligible, we do not consider that effect of electronic transition. So it has to be parallel or almost parallel. So this orientation is important because parallel to CH bond we require anti-bonding, and the CCl bond will be opposite to anti-bonding. So it turns out that the CCH bond and CCl bond have to be anti-parallel to each other to make the anti-bonding and the CH bond parallel to each other. So this constraint of parallelity for the electronic transition between CH bond and anti-bonding dictates that the CH bond and CCl bond must be anti-parallel to each other. This is very important. This, or if this orientation, if the constraint of this orientation is not fulfilled, then E2 will not take place, because as we can see how E2 is happening. Alright, so base will be giving its electron to the hydrogen, and in turn hydrogen will be pushing its electron into the orbital of carbon, and from the orbital of carbon, since carbon will not accumulate negative charge on its head, so it will start transiting that electronic density into the adjacent anti-bonding orbital. Now, as we know before from the previous lectures, that the bonding and anti-bonding together can hold maximum of 2 electrons. If by some other source electronic density in anti-bonding is increasing, then the electronic density from bonding orbital have to decrease. So since this anti-bonding is gaining some electron from adjacent CH bond, so the bonding electron, the electrons in the bonding orbital have to come out, have to go out somewhere else, and that somewhere else would be the orbital of this chlorine. So all these things would be happening simultaneously. Base abstracting hydrogen and electronic transition into the anti-bonding, and this chlorine effectively coming out of the substrate. Because when all the electronic wave goes into the orbital of chlorine, then there is no bond between carbon and chlorine, Cl minus comes out. Since in the one step reaction will be over, once the whole process is over, what will happen effectively is this hydrogen will go away with base, forming Hb. The electronic wave will go into the orbital, anti-bonding orbital, forming a bond between this carbon and carbon. There's already one bond, and another bond will be formed, making carbon-carbon double bond. So one of the product would be CH2 double bond CH2. That means we'll have ethene, and this Cl minus will come out. Right. So in one step the reaction would be over. This will be a concerted reaction. Concerted reaction meaning reaction taking place in one single step. So this E2 reaction taking place through E2 mechanism will be a concerted reaction, and this is the elimination. So E, and in the RDS, since there is only a single step, this single step itself is the RDS. In the RDS, there are 2 molecules. One is this substrate and another one is this base. So there are 2 molecules, so it is a bimolecular RDS. So molecularity of the reaction is 2, and hence 2 in E2. So E2 meaning elimination bimolecular, bimolecular meaning 2 molecules in the RDS. So this is the mechanism of E2. This is how E2 takes place. Now there will be some stringent requirements of this E2 mechanism. Let's see what are those requirements. The first requirement is that this reagent, there must be a base, of course. If we are having elimination reaction, there must be a base. Base meaning you have a reagent which is unstable. If that is a stable reagent, electron-rich species stable, that will become nucleophile. Now this must be very easy and very handy and very insightful for you. It should come very naturally out of you. If it is stable, will have a more tendency to act as a nucleophile. It is unstable. It will have a more tendency to act as a base. So when we say that a base is required, actually we mean relatively unstable reagent is required, right? So a base is required. For example, amide, NH2 minus, for example, alcoholic OH minus. These two are the common bases that we will encounter in organic chemistry. So this is of course one natural requirement. Base is required for elimination to take place. So when I said initially that I have moderated the reaction condition, that would also mean that I have taken such a reagent that will preferably cause elimination rather than substitution. So that will be one of the moderation in the reaction condition, this reagent. So I have taken such a reagent so that they are unstable, they want the reaction to be completed fast, and they would act as a base.